FIFO, or first in, first out. In this video, I'm going to talk about the first mechanism that we have in queuing or in congestion management. You know that we are using FIFO in the hardware queue also. Actually, in hardware queue, the only queuing mechanism that is supported is the FIFO, but in the software queue, we have different mechanisms that we can use them. Let me to review some of the mechanism that we have, and after that we will learn about the FIFO. About the congestion management, you know that we are trying to manage the congestion. What does it mean? It means that when we have more traffic than our bandwidth, okay, on the output queue, we need to use one queuing mechanism. This queuing mechanism is calling congestion management mechanism, and we can use one of these methods. For example, FIFO is in most cases is the default method, and we are changing the FIFO to one of these methods, for example PQ or CQ. Okay, and after that we have other mechanism, we call it modified deficit round robin, and other mechanism that you will learn about them in future. For example, we have a method, we call it class-based weighted fair queue first, weighted first queue, or WFQ, and after that we have other mechanism, we call it a class-based weighted fair queue. Okay, and also we have the next mechanism, we call it class-based weighted fair queue, okay, plus LLQ, or low latency queue. You will learn about them in future. Also, we have other mechanism, but in this video, actually, I'm going to talk about only FIFO, or first in and first out. This is the mechanism this is the only mechanism that we have in both software and also hardware queue. In hardware queue, the only mechanism that is supported is the FIFO, but other mechanism like the PQ, CQ, MDRR, weighted fair queue, class-based weighted fair queue, class-based weighted fair queue plus LLQ are working only on the software queue. All right, now, what is the meaning of FIFO? It is so easy. First in, first out means when we are receiving a packet, first come packet, okay, this packet should first served, should first forwarded, okay, and it means that assume that we in the router 1 now we are receiving 4 packets. These 4 packets after routing should send from other interface, for example from serial 10. Let me to show you, it is informative. Here we have one interface, fast Ethernet 00, and here we are receiving some packets, and the destination or outgoing interface of all of these packets after routing are serial 10. In the serial 10, we have a software queue. We need this software queue because if you don't have software queue, you should forward all of this traffic directly to the hardware queue. And in the direct queue, we don't have enough, in the hardware queue, we don't have enough space for the packets. Because of that, we need other logical queue. In this queue, we are gathering our traffic. For example, as you can see, we have received 4 packets, packet 1, packet 2, and packet 3 according to the order that we are receiving these packets. For example, packet 1 is the first packet, packet 2 is the second packet, packet 3 is the third packet, and finally packet 4 is the fourth packet. Because of that, we are gathering all of these packets inside the memory of the router, okay, and we will have one output queue, one logical queue, and here we have a pointer to those packets. Actually, if you want to know about the fact, in the router we have a buffer or a memory. Let me to write here, this is the buffer, our memory of the router. Here we will have, okay, all of the packets for all interfaces. For example, here we have the in the traffic of serial 10. The packet number is packet 1, packet 2, packet 3, and also for example packet 4. And also in this buffer, this is the buffer of router, maybe you have more than this, for example packets for other interfaces. Actually, each packet has a number, has a pointer. In the software queue, we have only a pointer. For example, 1 means packet 1, 2 means packet 2, 3 means packet 3, 4 means packet 4. And when we want to queue these packets, actually this software queue is not a physical place. Actually, this is only a list, only a list of pointers to the packets, okay? And when when the hardware queue is empty, assume that now the hardware queue, this is the hardware queue or a TX ring. Okay, when this TX ring is empty, okay, we can take the packets from the software queue, and after that we can send them to the, for example, TX ring. For example, in the TX ring now we have two space, and these two spaces are empty. Okay, and because of that we can we can send the packets from the hardware queue to the software, from the software queue to the hardware queue. This is the packet 2 and this is the packet 1. Okay, now packet 3 and packet 4 are waiting for being sent to the hardware queue. When the hardware queue is empty, the router, okay, should send according to the software queue traffic to the hardware queue. Okay, and because here we are using first in first out logic, the first packet that should be sent is 1 and the second packet is 2. Now the hardware queue is working for serializing these packets to the to the line, and after sending the first packet, for example packet 1, now we have one empty space. The next packet from the software queue is going to the hardware queue, and then again we can send the traffics, and after that other packets. Actually, software queue is a list of pointers to the packets that we have in the router buffer. When we are using the FIFO logic in the software queue, this is the software queue that we have, and now we are using FIFO. What does it mean? It means that we don't reorder the packets, okay? And when the packet receives first, we should forward it first, okay? The second packet, this is the second packet that we are receiving, and this is also the second packet that we are forwarding. Actually, we don't change the order. In most cases, the FIFO queuing is a default queuing mechanism, okay? And we don't use it when we want to apply quality of service. In quality of service, you know that we should give better treatment to some type of traffic, and after that we should give some priority from other type of traffic. Okay, for example, here when we are receiving packet 1, 2 and 3 and 4, okay, maybe the packet 1 is for example data. Okay, this is data, the packet 1, and the packet 4 is VoIP. Okay, it is recommended to first send the VoIP, not the data. But when we are using the FIFO, here we don't have any reorder. Because of that, FIFO in most cases is the default mechanism. We are changing the FIFO to other mechanisms, for example, to the class-based weighted fail queue plus LLQ. Okay, in this queuing mechanism, you will learn that we are sending the VoIP packet first. Also, in some cases about the usage of FIFO, we are giving priority to the VoIP, to the video, and after that for other type of traffics, for example, for different type of traffic, we are using the FIFO. It is possible to give priority to other traffics, and for the remaining traffic, we can use the FIFO. Finally, about the FIFO, we can say FIFO involves a single queue where the first packet to be placed on the output interface queue is the first packet to leave the interface. First come, first served. In FIFO queuing, all traffic belong to the same class. You will learn other methods of queuing, and after that you can better understand the FIFO. Here also you can see what is happening. As you can see, we are receiving these traffics with, for example, traffic 1, traffic 2, 3 and 4 and 5 and 6. As you can see, because this traffic is received first, this traffic is going out first, then the packet 2, and then packet 3, and then packet 4 and 5 and 6. In the FIFO, we don't have any priority. We don't have any difference between the packets. This is the default, for example, mechanism. Here we have a scenario R1, fast Ethernet 00 and serial 10. Let me to show you the default mechanism on the interface fast Ethernet 00. You know that for verification of the software queuing mechanism, you can use show interface, then the interface name. Look at here, show interface fast Ethernet 00 can show us that the queuing strategy is FIFO. This is the default queuing strategy on the fast Ethernet 00 of this router. But about the serial 10, show interface serial 10 can show us we have other default strategy. Look at here. This is the default strategy in my iOS for serial 10. okay, weighted fair queue, and also the default strategy for the serial 10 for the fast Ethernet 00, as you saw, is the FIFO. Okay, it is related to iOS, but let me to remove the weighted fair queue. You know that this when we don't have any other mechanism, okay, it means that we are using FIFO. Look at here. On the interface serial 00, as you saw, we have the weighted fair queue, as this is one of the mechanisms that you will learn about it in future. But for now, I want to remove this mechanism with this command, no fair queue. With the no fair queue, you are removing the weighted fair queue mechanism from this interface, and the interface after that will use the FIFO mechanism. Here in the router 1, let me to show you configure terminal interface serial 10. I'm going to use no fair queue. Look at here, no fair queue, that's it. Then show interface serial 10, it can show us now this interface also is using the FIFO. Actually, when we didn't configure any command, okay, in most cases we are using FIFO. But if you have one method of queuing by default on the interface, you can remove that method of queuing, and after that you will have the FIFO method. In most cases, when we have QoS, okay, in our company, in our enterprise, we don't use FIFO in most cases. In some cases, when we have other mechanism like the class-based weighted fair queue plus LLQ, we are using the FIFO for remaining traffic after giving priority to the VoIP, to the video, to the other type of important traffic for us. We can use FIFO for remaining traffic. It is other usage of the FIFO. You will learn about it. About the FIFO, we don't have any, for example, important configuration. Actually, when we don't have any configuration about the queuing mechanism, we are using FIFO. Okay, that's it. You will learn about the other mechanism in the future videos. Now we know about the simplest mechanism of queuing, and the name of this method is FIFO. Don't forget, FIFO also is useful for us. Assume that we don't have any queue at all. Okay, means FIFO queuing is not available. The traffics cannot be saved into the buffer of the router. Because of that, they should drop, because the capacity of the hardware queue is not so high. Because of that, we didn't have the packets, and the packets should be dropped. Because of that, FIFO also is useful when we are using best effort model of quality of service, or BE, that you have learned about them before. But when we are using, for example, differentiated service model of implementation of the quality of service, we don't use FIFO in most cases. We are using other methods. Let me to talk about the next method of congestion management or queuing. We call it PQ, or priority queuing.